Yeah, my name is Anna Xambó. I'm based at the Montfort University. Yeah, teaching and doing research there around the MTI, Music Technology and Innovation Research Center, Institute for Sonic Creativity. And I will now share the slides for this presentation. You should see now. Yeah. And as Federico was mentioning, this talk is on data-driven sound-based music, and which basically departs from sound-based music and then brings the data layer into it. And so the idea will be to do a little of a journey of sound-based music, what is data-driven music, potential from the live coding space, and then some future directions. Second. All right, so the context of sound-based music and data-driven sound-based music sits within the sound and music computing discipline, which is by nature multidisciplinary. So basically, it brings science or scientific, artistic, and technological methods into the playground. And the objective is to look at understanding, modeling, and generating sound and music using computational approaches. So then if we look into the recent trends in the SMC, we can find the use of the latest AI algorithms applied to music. And also we can see a promotion and interest to promote more inclusive approaches to music making. So just to list some of the topics of the main conferences or key conferences of SMC, the topics that they suggest authors to talk about are artificial intelligence and music technology, machine learning for music, or also intelligent audio engineering, music information retrieval, and so on. And from the side of bringing more diversity and inclusiveness, we find approaches to decolonization, decolonizing music and musical interfaces, also designing by and with disabled neurodiverse musicians, or bringing more accessibility and consider special needs in the design of SMC applications. Another common aspect that is used in SMC are datasets, and that connects with data-driven creative applications. And what we are finding like lately is that the datasets are exponentially growing. And that means also that the way of navigating and exploring this data can be done creatively and with new ways, original ways to do that. So as the outline of this talk, there are three main parts, and we can see them as looking at the past, the present, and the future, or what can we consider data-driven sound-based music. So for the past, we will look into sound-based music, some classics, but also when data-driven sound-based music comes into play, and what are the new challenges and opportunities that this approach brings to music, sound-based music. Then we will move into the present and explore live coding examples as a suitable testbed space to explore this manipulation of data in the real-time space and using MIR and AI algorithms. And finally, we will move to the future. From these live coding examples, we will more pose questions more than give answers about potential data-driven music applications, what are the open questions that live coding can bring into the discussion, and how this practice-based approach can inform the future design of data-driven applications. So we move then to this first part, which is looking at the past, the legacy, and how the data-driven sound-based music takes shape, and what challenges and opportunities bring. And we start with Luigi Russolo, um, that does, yeah, it's a well-known Italian futurist who basically, well, first he wrote the Art of Noises Manifesto in 1913, where there is a kind of a promotion of bringing other sounds apart from music notes into consideration for music composition and music performance. And then Russolo developed during some years the internal rumori, or these noise machines or noise tuners, that basically they are acoustic instruments, but that explore other sonorities and timbre. And of course, as we know, Russolo is a precursor of concrete music, noise music, and acoustic ecology, among others, which we will also look in this kind of revision of the past. And the art of noises can be seen as a key reading in contemporary musical aesthetics. So we can just briefly watch this video thumbnail here, which is a serenata for this internal rumori and instrument. And this video, I can give the links later if interested of all the videos that are in this presentation. The date is unclear, but it's presumably it was recorded around 1920. And we move on in this timeline of key contributors to this sound-based music approach. And next stop is Pierre Schaeffer with music concrete. And so Pierre Schaeffer continued in a way the line established or envisioned by Luigi Russolo, and explored the use of sounds as compositional or raw material. It's known as being the first composer to make music using magnetic tape. He founded the GRMC in Paris in 1951 with all the also connected composers exploring this approach, and is seen as a pioneer in contemporary recording and sampling techniques that later have been used or applied in the digital domain. And then moving on with this selected key figures, we move to Murray Schaeffer in Canada around the 60s and 70s, but mainly 70s. He founded the World Soundscape Project in the late 60s at Simon Fraser University in Vancouver. And basically, he's known to explore the notion of soundscape connected to acoustic ecology and soundscape studies, but basically exploring the surroundings, the environment, the ecology as part of the listening experience, and also what are the effects of certain sounds and noises. Yeah. And moving on, so there's also in the 80s the emergence of the kind of the popular computers, and a figure that it's nice to highlight here because of the connection that has with sound and music computing and sound design is William Gaver, who has, Gaver, who has different contributions, not only in sound. There are the cultural probes, for instance, but in kind of within this area of sound-based music, he brought this idea of using sound recordings applied to the computer interfaces. And so there is this sonic finder, which is a prototype developed in the late 1980s in Apple, where he's exploring like interaction gestures and actions and variations depending on the digital kind of units. So say, for instance, dragging a folder in a trash can, depending on whether the folder is full of files or not, and the distance of this dragging will have a different sonic effect or output. And then another key figure here is John Oswald and the Plunderphonics. So there is a wide range of musicians, composers exploring digital sampling. But John Oswald is important here just because of the way of exploring Plunderphonics, which you can see here definition. He's doing digital sampling somehow, but he defines it as a particular craft, manual craft of making music from existing recordings, with the distinction of making these recordings this kind of recognizable. So this plunderphone, as he defines, should be a recognizable sonic quote, where using the actual sound of something familiar, which has been already recorded. So basically recognizing something popular or familiar that's kind of interest for John Oswald. And then that brings also or brought some kind of copyright issues with the recording industry. And that's why this example is relevant here, just because it also brought some questions at the time about using samples that can be recognized, and maybe why copyright licensing was too strict for this kind of practice. So we see on the right, we will watch a little bit of a video by John Oswald's Plunderphonics, which is an official video of a song by Michael Jackson remixed. And that was re-edited and reproduced by John Oswald in 1988 in a film by Martin Scorsese, redirected and re-edited by John Oswald later in 2014. Then we move on into, like, there is a big jump here in the timeline, but yeah, just to highlight Leland's approach to sound-based music and the kind of the well, stressing the kind of the inclusive side of this approach of making music. So sound-based music understood as this art of sound organization. Leland is kind of finds a connection with popular music, and how this direct connection then can make it more accessible to all. And so he has these publications making music with sounds, and also the book chapter Sound-Based Music for All, and this connection with education, and how then as a pedagogical tool, it's a way of kind of attracting this practice to all kind of people with all ages, abilities, and backgrounds. And that's also connects, I mean, Leland is the director of the MTI, the Music Technology Innovation Center, but also connects with the Electroacoustic Music Studies and this project EARS, which is an online resource where there are also these some exercises and resources for education. And then, yeah, so from all these kind of pre-internet, if you like, examples, we then move to the influence of audio signal processing and MIR. And so here there are 3 examples just to show the different possibilities about then listening to the music and the sound descriptor, some properties, and then what can we do out of it. And so here we see, for instance, from Nick Collins, the BB Cat application, and that was built in 2002. And then we find a kind of a remake called LiveCat in 2013. And this is made by MDSP Smart Electronics. It's basically about bringing one audio file and then slicing it algorithmically and automatically. Let's just watch a little bit of this. And then we have, we can also find from the music technology group in Barcelona, they developed this commercial VST plugin LoopMash, which is this tool for instant slicing and reassembling audio clips. Basically, you have a target sound, and then from this target sound and the sound descriptors, then you can build, using this audio mosaicing approach, you can just build as kind of a sound collage. And then we have Diemos Vars with Qatar as well. We can watch the video as well. So this has been posted by IRCAM, and basically is an interactive corpus-based interface that is based on concatenative synthesis, where there are prearranged snippets that are arranged by similarity, and then you can navigate through them using a GUI or TUI, or tangible user interface. And then we move to 3 other examples from the influence of the internet. And we start with Sangwon Lee's using the YouTube API to create an audiovisual mashup of YouTube videos using a live coding environment. So you can then do video replacement and playback in real time.
Other people to do. It kind of broke my heart. 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 It kind of broke my heart.
We can also find Ariane Stolfi's music performances using playsound.space that she has developed, and which uses the Freesound API and then queries sounds by text and navigates through their spectrogram, so very much based on the visual information. And the final example about using like large collections of sounds, online web APIs is Gerard Romel's Floop, which is an environment that also uses the Freesound API. And in this video, it supports collaboration. And basically you retrieve loops based on rhythm, constrained by rhythm, and they are organized by timbre. yeah, just to say for Xambó Lee's video that was presented in 2017, yeah, at NIME, Ariane's video and performances are related to the Web Audio Conference last year, and FloopJam also relates to the Web Audio Conference, yeah, last year. So yeah, Ariane is 2 years ago, sorry. Just to give the right context, otherwise, yeah. Okay, so then just to conclude this, the past in a way, and how data-driven sound-based music has brought new, say, opportunities, challenges, but also, yeah, and new questions. So we've seen with these last 2 slides, with 6 examples that audio signal processing, MIR, and the internet have brought this possibility of treating the audio as data and more automatic mechanisms and processes compared to the previous examples. So that's a change. It also has brought new techniques and new ways of dealing with this data and producing sound. The opportunities, and these come like from the examples in a not sequential order, but we've seen inclusiveness, sound-based music, and data-driven sound-based music by extension bring more inclusiveness. We can see the wall as a sampler, and there are examples you can check as a follow-up from the kind of the legacy of Murray Schafer. So Barry Trax and Francisco Lopez, they've been exploring this approach of using the wall as a sampler. Then also we've seen with the use of sounds from FreeSounds, for example, or other online databases, that there is this algorithmic music by chance that can be produced. And also we can see the use of sound-based music as an alternative and a suitable way of approaching creative AI, that this can be complement or be different from symbolic music. Challenges: there are technical and legal requirements and consequences of dealing with data, as we've seen with the previous examples and we will see later. And also there is the manipulation of data in real time, can be seen as still a challenge, but it also can be musically interesting, and that's something we will look now in the next section. So live coding in its broadest sense can be seen as the perfect nexus, and that's what like this section is about, between data and music performance. Because in a way, data can be shared as part of the live coding practice where code is already shared with the audience. Data can be also shared. So that's a way of keeping, yeah, kind of expanding live coding and the transparency of code with the addition of data. So you see here. And so in this section, we will see 3 different approaches of dealing with data in live coding as interesting examples, which also bring some questions. And the first of these 3 areas is AI-powered live coding environments. So we can see that there are several, well, it's highlighted there are several instances of traditional live coding as music performance that are enhanced with virtual agents and that use AI and machine learning algorithms. And we will see 3 examples. But just, yeah, to mention that's a corpus of approaches in live coding doing this kind of approach. And we start with Utopia, developed by Nora Lorway and others. And basically, Utopia is based on code generated from genetic algorithms. And an interesting or, yeah, distinctive approach of Utopia is that they use the fitness function of these genetic algorithms to kind of like is informed by the audience behaviors. So the audience can vote using their smartphones, can vote whether they are liking or not what is playing, and that this affects the next generation of the virtual agents. And you're welcome to watch the videos on Vimeo. Another approach is the Milka, which is this MIR and live coding automatic. And that's basically is exploring the use of machine learning and MIR to retrieve free sound crowdsourced sounds. And yeah, so this builds on top of the Milk library that I've developed, which builds on top of the free sound API for Super Collider. And this extra layer that uses machine learning and MIR is built on top of the Flucoma, which is this environment for music performance that implements machine learning algorithms that work for both Super Collider and Maximus P. And so basically, this Milka, what it does is to retrieve sounds from free sound, but there is a kind of an agent that has been trained, so it filters only the sounds that the live coder has trained as good sounds. And we move on. And there's also Xambó version 2, 2020. Well, I mean, they've developed version 1 previous to Xambó version 2, but I'm selecting Xambó 2 because they are using, as kind of the training data, they are using scripts, tidal cycles that I'm seeing Alex Macklin here, tidal cycles scripts from different performers to train this agent that then kind of performs from what has learned from this data. So tidal cycles is basically an environment built for create live coding in a rhythmic fashion, if you like, based on patterns. And basically, yeah, Xambó is built on top of that using this language. And the idea with this agent is that it performs solo. So that's why we will see in this video that was presented at the ICLC International Conference of Live Coding in 2020. Basically, the performer just leaves the agent by its own. Yeah, so this would be the first area within this live coding as a suitable testbed space to explore data manipulation. Another area of interest is audience-centric performances. And seeing that audiences' mobile gestures have been used basically through their smartphone sensors to create what is called these audience-centric music pieces. And we can see this as a type of live coding because the audience produces code that maps to music in real time. And we will see also 3 different examples of this approach. We start with the Do the Buzzer Shake from 2016 by Roma and others. And basically, in this piece, the audience mobile accelerometer gestures drive the musical piece. This was presented in the International Conference of Live Interfaces in 2016. Then we moved to No Merge Conflicts by Roma, which was presented in Web Audio Conference 2018, where you will see here there is an artificial agent that basically selects from what the audience is doing with their gestures and touch inputs, and then just creates an audiovisual algorithmic composition out of it. And then the final example, this is like an ongoing project together with Vista Gudarsi, where we're exploring kind of how to complement network music with the audience presence, and doing that through the audience location and gestures via their smartphones, and map that to audiovisual output that can complement kind of the network music piece. And we will be presenting this approach in the next NIME this summer. The third area of this kind of live coding exploration, or as a suitable space, is live scientific data. And we will see with 3 examples that scientific data has been used in live coding to understand the data, to raise awareness of this data, to promote public engagement, and to disseminate scientific results, among other possibilities. So that it's quite promising and open space. And we start with this data to music API. This has been developed by Takahiko Tsuchiya in 2015 at Georgia Tech. And this is a browser-based JavaScript API for real-time data sonification. So as you can see in this example, that means you can easily create, so say from data, and in this case is an array of numbers from 1 to 5, map them to, for instance, notes that can range from 60 to 90, and then play that result. Another example is data jockeying. And this is a practice that is widely explored and developed at Ritmo in Oslo, at University of Oslo. And so in this example, we will see Dongo Daniel Kwak doing kind of a show and tell of data collected from a music lab that was done on a day. Rhythmo create like these labs basically, and there are different activities. So for this session, there was some data from music gestures, and then Dongo Daniel is just sharing this show and tell of how to deal with this data. What do we do as researchers? So just cleaning the data and then just thinking aloud about when we deal with data and prepare it for research.
These biodata tend to be very noisy, and that can be due to many different reasons. And we always have to compensate for that, and spend quite a bit of time on actually just filtering out these noise and clearing up the data so it becomes more useful for analysis and for research purposes.
And then we move to the third example of live scientific data, and this comes from the Data Art for Climate Action kind of event that happened earlier this year. And there was this curated piece by Rennick Bell and Moon, where they are using weather data from Hong Kong Observatory. And then the idea is to showcase the change of number of hot days and nights from 1884 to 2021. Yeah. So we move now to the future, the third section. So what can we learn from these different live coding approaches to dealing with data, and how, what can we learn, and whether it can inform future data-driven music applications. There are some continuums that I would like to highlight. One is this maybe continuum or combination, if you like, or could be either or both, of these private versus public collections. So this input data of combining personal and public sounds looks promising. We've seen examples of either personal sounds or public. We've explored this combination and it looks promising. So that's something that can be considered. Then also this from micro to macro level. So we've seen also examples of input data that has constrained features, and that could be duration, but then maybe, and usually that goes with micro approach or macro approach, but maybe this combination of both can be also interesting and provide different musical results. Another interesting continuum is from situated to agnostic data. So we've seen with this external data, they tend to come with metadata. So using that also as part of the kind of the music composition, music performance can be interesting, but also maybe just removing that part, making it more abstract can be interesting, or combining both. This is another interesting continuum. And there are, as mentioned at the beginning, more open questions than answers. One is about this data transparency. As mentioned with live coding, there is this tradition of sharing the code and by extension now the data. So to what extent can we share fully this data transparency. Then also data privacy. So the fact of using data from, say, the audience, sensors, location, this can raise some issues as well. So do we have the right framework for that? Data authorship, which this is already brought from digital kind of sampling onwards. Who's the author? And now with virtual agents, who is the author? Is it relevant to discuss that? Data ownership as well. So is it important to take ownership of the data? Shall we produce the data? How does this connect with authorship? Data bias, this is a recurrent important issue. When we produce data, can we be neutral? Shall we recognize the bias and then address that? And then data access, can we access to all the data? Are there any constraints or limitations? Is it democratic for everybody? So in conclusion, we've seen that manipulation of data in real time is still a challenge, but it can be musically interesting, as we've seen with the different examples. Then live coding, we found that enables an interdisciplinary exploration of data in creative ways that go beyond the traditional live coding music performance. And then this dialogue between data and live coding practices can inform future data-driven music applications, and that speaks about the techniques, musical techniques, the technical requirements, and illegal boundaries just by practice we can find, and then also community and social phenomena, among others. So this concludes this talk about data-driven sound-based music. So I'm happy to take any questions, and thank you for your attention. I'll stop sharing now.
Great, thank you, Anna. That was a very thought-provoking presentation, and very relevant to to the network as well, and all of the questions that we're trying to kind of like to think about and gain some insights from. So thank you very much. Are there any questions from the people in this group?
If there aren't any questions, I can ask one. This idea of democratic and open, and that it's kind of inclusive, the fact that data or that you can grab data from free sound makes it automatically inclusive. And I'm wondering if that is theoretically true, but practically not. I mean, then by analogy, when we just started being like at the early stages of music streaming and also film eventually, there was this theory that the internet is going to make everybody equal and everybody is going to be and kind of musicians can break through and it will be very democratic. And of course, it never happened that way. Actually, things actually concentrated because there is so much junk that everybody can post that it's difficult to cut through that junk and be recognized. And actually, I think artists are it's even harder. And the resulting music is actually narrower. So the kind of music scene has not actually expanded into kind of democratic, open and stuff. So in what way? It's what I mean by theoretically inclusive is that a lot of sounds are posted out there, but the sounds that are actually actually findable are predominantly kind of very narrow range. So is it actually inclusive, or what do we mean by inclusivity in that sense? Can be kind of maybe queried.
Yeah, thanks for this thought-provoking question. But yeah, I guess when in this presentation talking about sound-based music and inclusiveness, it really is inspired by Leland's approach to it, which is probably more based on the idea that you can produce music by creating the sounds yourself, or taking sounds. It could be from Freesound or anywhere else. It maybe doesn't really matter, but the practice is kind of affordable for anybody to take. But then there's, as you mentioned, there is a digital divide at present. Also the interfaces, if they are too complex, that's also another layer. So yeah, I guess inclusiveness sounds nice and right, but then what do we mean is a good question, actually. What do we mean? So for the Milka project, for example, something that was interesting to see was the community or of live coders making the tool or taking ownership of the tool, creating the data by themselves, selecting from the sounds that were coming, or they were retrieved from Freesound, and they could say, I like this sound, I don't like this sound. So there was like this ownership of the tool and of creating a data set for themselves, or training a model for themselves, and then using that for their performances. That could be seen as democratization, or a prototype of democratization, in the sense that the live coders could make it their own in a way, and understand these algorithms by their own practice. But yeah, I think it's a big topic, difficult one. And depending on the context, it means something or something else.
Thank you, Anna. Any other questions?
Yes, thank you, Anna. Thank you. Thanks a lot. To follow the question of Oded, hi Oded. I mean, there are a lot of languages, protocols, and really nice experience you have presented. I just wonder, from your experience and studies, how far we have, in a way, some maybe an opportunity to have something better built for some users, some archivists, or maybe some students or musicians, to provide more and more data. And I think we have a problem dealing with that. We have a lot of protocols, but we don't really have some models, some formats to be able to share some data between us. And I just wonder, besides, the various APIs, for example, Freesound, which is very good, what are the opportunities for us to provide some data in a way, in an easier way on the networks, so that maybe our live coding systems could bring data and really in a easier way that we have now, because dealing with really specific APIs, if we have a lot of ones, it's really difficult to build something inclusive in a way, and it's not really thinking about a universal system or format, but just to be able to share something easier. What do you think?
Well, first it connects with this project, the Audio Commons project, that was developed at Queen Mary, the Music Technology Group, and Surrey University, where there was this research question about all these different APIs. Can we provide an ecosystem where we can kind of bring all together the needs of the contributors of, say, sounds or other data, and then the consumers and producers? So how can we deal with all of them? But I guess, so with online technologies, they change so fast. So since early internet days, but it is to create standards, right? And these standards should be kind of the umbrella to protect that the different APIs talk. But it's another, I agree with you. It's another complex issue. So like from this Audio Commons project, from these research projects that explore that to the implementation and realization, the APIs have already changed. So I guess there's also this speed of the internet technologies that don't help. But yeah, I agree that we are getting more APIs, more data, and some kind of standards or ecosystems that are kind of change with the APIs technologies are needed. But yeah, I don't have an answer to that. I agree that it's a problem.
Thanks.
But you were working, right, with an archive,
Yes.
isn't it, at your camp?
Yes, there are some standards coming up, especially coming from image applications. And there is a working group on that to have an open standard for sharing sounds, but it's really based on metadata for sounds. Maybe we could maybe improve this for music, especially because metadata are not really music oriented, but it's a nice direction, I could say. I will share a link in the chat. Thanks.
Thank you.
I noticed there is a question in the chat. I'm just going to read it. Hi, I'm invested in the idea of sound design with data and how we decide to map parameters to data points. My own experience is to go with what sounds good, but when are we compromising the data? Is there a good approach you could recommend that allows us to reveal the data sources?
Well, then yes, there is a paper. This is first author is Gerard Roma, and the idea here is to explore kind of what the data can tell you. So kind of learning from the data and then retrieving what are the kind of the interesting parameters using machine learning. So maybe that could be something you could have a look at as an approach. And it's based on also Flucoma technology. Let me, 1 second. So that's, this is the one. But yeah, so the idea is maybe using machine learning, right, to kind of let it tell you what's interesting. Oh, the title, yes, sorry. It's a general framework for visualization of sound collections in musical interfaces. Yeah.
Great, thanks, Anna. I think there's a question from Hussein Bun.
Yes, that's right. Hey, how you doing? Thank you very much for your presentation. I suppose the thing is, it's still following on the idea of data and formats and so on. I mean, one of the things I'm really interested in is partly with the intersection with things like copyright law and IP and stuff. So something like the LAC database, which is basically the MIDI database that is used to test the fitness of the audio machine learning. So where they have a MIDI file, they can test the degree to which the audio is matches kind of the MIDI and so on, so that then they can build a kind of a confidence index based on their machine learning, based on the MIDI and audio, how close they can actually get to modeling it. So something like the LAC database I find really interesting because basically it's basically a screen scrape of the internet for every MIDI file that's ever been known to mankind, right? So quite a lot of those MIDI files sort of breach copyright because you're not allowed to disassemble a master recording. You can't place it in a different format without actually the prior agreement or permission or license of the original copyright holder of the master right. And then added to that is also, like I've read a couple of the PhDs that have been based on the LAC database, and the LAC database basically has a lot of orphan files in it. So basically from copyright law, if you can't trace the owner, you actually can't use it. So the interesting thing about machine learning is that you basically have a lot of machine learning products being based around orphan files, which in turn will then create a new copyright that they will try and enforce. And of course, no one will be able to ever tell whether it's been, you know, the provenance of where the data has come from for them to actually test the kind of the fitness. Unfortunately, there isn't really a question in there. It's just really an observation more than anything else, I'm afraid, Anna. But I think it just indicates the sort of, the really sort of twisting, sort of turning, sort of ethical nature of just, where is all of this coming from? You know, what sort of data and what kind of licenses people feel that they may or may not actually have. Because the assumption is that if it's online, it must be free, right? You know, so yeah. So there isn't really a question, I'm afraid, but thank you very much
Yeah.
for the presentation.
Well, I just wonder why not Creative Commons licenses, which there are different
But they didn't
layers.
Yeah.
Right, and
But,
so it's
sorry.
surprising that, you know, I mean, maybe we should require, right, to use CC licenses whenever there is machine learning involved. For but it's surprising that in 2022 we are still like dealing with, you know, right, with the copyright, and then how then can we?
Yeah,
so I just want,
no, go on.
No, I just wonder then how, so probably that sounds like a trap, right?
It does feel like something of a trap, especially when you look at things like explainable AI. Like, so essentially, like if we start to use AI or machine learning and it arrives at a kind of an output, and then it has to also explain what elements have actually gone into that kind of, to make that output in terms of decision making and whatever else. So I can kind of see a whole bunch of stuff where actually, you know, machine learning AI tools like from Spotify and wherever else will actually obfuscate where stuff comes from, because they don't want to have a lawsuit. So they don't want to say, oh, we've taken it from here and we've just modeled it, right, and fiddle around with it. So it's definitely a bit of a minefield. But yeah, but thank you very much for your presentation.
Well, thanks for the comment.
No question. I'm really sorry.
No, well, but it's good thinking about.
Thank you.
Great, thanks a lot. I think there's one last question again from Oded. Oded, do you want to ask the question?
Yeah. So it's about the instances where you had audience interaction through mobile phones. And I think it's kind of a weird situation in terms of aggregating data from a lot of people to influence what they see and what they hear. And the challenge with making them feel like they're actually involved, they're actually doing something, when, you know, if it's one action among 20, it's difficult to see how what you're doing is going to. So can you tell something about how you navigate that, or what's your approach to making that work or interesting? Or
Yeah, well, thanks for the question. Yeah, this is also, I mean, there are plenty of possibilities. Something we've explored, like the hyper-connected action painting. Here we were exploring the use of gestures mapped directly to painting gestures. And that was a canvas that was projected. So that should be maybe more kind of clear for the audience what they were doing with, like, there were 3 main gestures, and that would map to these brushes, different brushes or brush gestures. Other approaches, so with Visa's collaboration, we're exploring like the location map to also a canvas, and then the kind of the different accelerometer sensors would map to like more subtle movements. But these 2 examples come from like, they are more based on audiovisual kind of feedback, but the visual presence as a helper for this. Then, yeah, I guess for the sonic space is more difficult when there is so many people. Gerard Roma's approach with the agent was more like just picking here and there. So then it's maybe unclear. We should ask the audience probably whether they were aware when their bit was picked and showed. But yeah, it's an open question as well, and we are in the early days as well with these audience-centric approaches. Yeah. The other comment is that usually with different pieces we've explored, the audience gets tired also. So then how to make it like either we just make it less, demanding for them, or how to make it, attractive throughout the piece. That's also an open question. But yeah, it's good for every piece just to explore one angle and see. Yeah.
Great. So I think we have time for one more question, and Alex has his hand up. So Alex, go ahead.
Thank you, and
hello.
Yeah, I was just wondering. It was a really nice talk, really expansive, but that makes me think: does a non-data-driven computer music performance exist? What it would look like, or is data-driven music more about looking at computer music in a certain way?
I mean, of course, there are, multiple approaches to live coding music making. So this is one way. The reason data-driven, well, I guess it's the context of this network, which also speaks to this sound-based music and using data-driven. But yeah, it's an approach. It's a, to me at least, I see it as a lens, right, to explore. And now it's timely also because of this massive data everywhere. But there's also data-driven sound-based music. Yeah, I think so, right?
Well, I guess what I'm saying is that sound is data, code is data, as you've shown. So it's hard to imagine a computer music performance, at least, that doesn't involve data in some way. It could be interesting to try and come up with one.
Yeah, I mean, I guess, as you say, it depends on what you define as data, but from your definition, yeah, that's a good question. Maybe it's just the vacuum, right? It's just the white canvas.
Yeah.
That's a good question. It's a good question. What is data?
Yeah.
But I guess we can ask the network, right? These network organizers, how do they define data? Is it?
Well, that's a big question. Well, basically, part of the idea of the network is that we precisely question that, and that we kind of like try to come up with some ideas of what's the gap between what we ordinarily called musical data and what we could say is something like musical knowledge. So, in other words, what are we missing in terms of musical knowledge when we are capturing data that it has some sort of musical sense? So the question for us is more, it's more to formulate actually these questions of precisely what is this data precisely capturing, if that makes sense. And for us to also understand what it's not capturing as well, which I think is also an interesting question. And obviously, there will be more conversation about this through this network. And in fact, this Saturday on the 30th, we have our first big event, and some of you will be joining us in New York. So we look forward to welcoming you here in New York to continue precisely this conversation. And also, I just wanted to also point out that the next virtual seminar will be on the 30th of May. So please join us for that as well. Anna, thank you very much for your presentation. As I said before, very thought-provoking, and thank you very much. And thank you everyone for coming and for those really interesting questions.